Good morning. Today we're covering section 3.3, Systems of Linear Inequalities in Two Variables. Very similar to what we covered on the last chapter when we had one inequality. But now, because we have two inequalities in one problem, that's called a system. Remember, a system is whenever we have more than one component. So we have one inequality, two inequalities, and they'll be graphed on the same graph. A solution of a system of linear inequalities is an ordered pair, x, comma, y, that is a solution of each inequality in the system. So in order for a point to be a solution, it has to be on both inequalities. It has to be true for both inequalities. It has to be a solution for the first one and also a solution for the second one. Graphing an inequality, remember, if it's less than or greater than, it will be dash. If it's less than or equal to, greater than or equal to, is a solid. And we can do it both ways to graph an inequality. We can first graph the boundary line, then test a point that's now on the line to decide whether we're going to shade the top or the bottom. Or to decide if we're going to shade the top or the bottom, we can decide if it's less than, we're going to shade down. If it's greater than, we're going to shade up. So if it's less than or equal to, we're going to shade down. Greater than or equal to, we'll be shading up. And you can use either method. Just select a point to see if it's a solution. If it's not a solution, you can shade the other side. Or you can just look at the inequality to decide if you can shade the top or the bottom. Let's look at example number 1. For example number 1, we have two inequalities. First, we need to graph the line. So let's go ahead and solve for y. You can also find the x-intercept, the y-intercept, and the x-intercept. But let's go ahead and get used to just solving for y just to be able to practice the skill. And especially sometimes you guys will get a fraction if you solve for the y-intercept or x-intercept. So first thing, I'm going to move the 2x to the right. When I move it to the right, it becomes a positive. So I have 3y less than. Remember to write down your x first, and then your constant. Now we're going to be dividing by 3 to leave the y by itself. The 3's cancel. So we have y is less than negative 2 over 3x minus 2. Remember, now that we solve for y, we can find the slope and the y-intercept. So we can easily graph it. My y-intercept is negative 2. My slope is negative 2 over 3. So I'll go down 2 and to the right 3. Down 2 to the right 3. Or the opposite. Up into the left. Up into the left. Using my ID, I'm going to draw a line. Remember, if it's dash, if it's less than, it's going to be a dashed line. So just make a dashed line. Then from here, I need to decide whether I must shade the top or the bottom. If I look at the inequality, it says less than, so that means I'm going to be shading the bottom. I'm not going to any of these points and just down arrows on each side. I'm going to use a color pencil so you guys can see where they both intersect. So I'm going to shade the bottom part. Nice and light. Now I'm going to do the same thing with the other inequality. I'm going to go ahead and graph it. So I have negative 2x plus y is less than or equal to 3. I'm going to go ahead and move my 2x to the right. That's going to become a positive. We have y is less than or equal to positive 2x plus 3. My y-intercept is 3. My slope is 2 over 1. So I'm going to go up 2 and over 1. Up 2 to over 1. Or the opposite. Down and to the left, 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 down and to the left. Remember, if it's less than or equal to, it's going to be a solid line. Once I have the line, I need to decide whether I'm going to shade the top or the bottom. So I look at the inequality. It's less than, so I'm going to be shading the bottom, and the bottom. I'm going to use the blue color pencil to shade the solutions for this inequality. So in orange are the solutions for the first inequality. In blue are the solutions for the second inequality. The solutions for the system, for both of them, are where they intersect. So this are the solutions for the system. Now remember that the reason that this line is solid is because even those points that are on the line are part of the solution. If you notice, this line is dashed because those points that are on the line are not part of the solution, and that's the difference. Let's go to example number 2. On example number 2, we also have a system of inequalities. We're going to go through the same process. We're going to leave the y by itself so we can graph it. So I have x minus 3y is less than or equal to 3. I'm now going to move my x to the right. That's going to become a negative. So currently it's a positive. I'm going to move it to the right. It's going to become a negative. I have negative 3y less than or equal to negative x and then plus 3. Remember to write down your x first and then the constant, the number. So I'm going to divide by negative 3 to leave the y by itself. Negative 3 is cancelled, y, and when I divide by a negative number, don't forget to flip the inequality. Negative divided by negative is going to be a positive. Don't forget about your invisible 1. 1 divided by 3 is not 3, it's 1 over 3. Cannot be reduced, so we have an x. Positive 3 divided by negative 3 will be negative 1. So from here I can graph it. My y-intercept is negative 1. My slope is up 1 and to the right 3, up 1 to the right 3, or the inverse, down and to the left, down and to the left. Because of the inequality, this is going to be a solid line. Remember, if I'm going too fast, just go and pause, and then you can always rewind. Now I need to decide if I'm going to be shading the top or the bottom. It's greater than, so I'm going to be shading. Remember, if it's less than, you're going to shade the bottom. If it's greater than, you're going to shade the top. Less than the bottom, greater than the top. So this is going to be the top. You can also select the point, 0, 0. Test if it's a solution. If it's not a solution, shade the opposite side. If it is a solution, then you can go and shade that side. But much easier, if it's greater than, just shade the top. I'm not going to use my orange to shade the top. Then I'm going to do the same thing with the other inequality. I have x plus 4y is less than 0. I'm going to move my x to the right. It's going to become a negative x. So I have 4y is less than negative x plus 0. Then I'm going to divide by 4. Divide by 4. Divide by 4. The 4's cancel. So we have y is less than. Don't forget about your invisible 1. The leading coefficient, or the coefficient, will be 1 or negative 1. So we have negative 1/4 x, and then 0 divided by 4 will be just 0. My y-intercept is 0. My slope is down 1 to the right 4, down 1 to the right 4, or the opposite, up into the left, up into the left. And in this case, it should be a dashed line. Now I need to decide if I'm going to shade the top or the bottom. If it's less than, that means I'm going to be shading the bottom. So I'm going to shade that with my blue pencil. Now the intersection is where both shading intersect. Remember, the blue are the solutions for this one. The orange are the solutions for this one. The solution for both is just this triangle. Now, many of you guys are going to start, instead of just shading both sides, you might want to just draw the arrows. And if you notice, both arrows are pointing to this triangle. Both arrows are pointing to this triangle. That's how the solutions, and that might make it much easier and a little faster for you guys to identify the solution. So this one down, this one up, so you should shade this triangle. Both of them are pointing to this triangle, so you can just shade the triangle instead of having to shade both of them. So let's go and continue with example number 3. On example number 3, we're going through the same process. We need to graph the following system of linear inequalities. We have x is greater than or equal to -3. If you guys remember, we need to decide if this is a vertical or horizontal line. One easy way to remember if it's vertical or horizontal, we have x and y. If it's x, it's going to be v. If it's y, it's going to be a horizontal. So x is a vertical, y is a horizontal. Many of my students will remember Vanessa Hudgens or Van Helsing. So whenever you write down x, y, just write down Vanessa Hudgens or Van Helsing. In this case, x, that's going to be a vertical line. Another way to remember how to graph it is on the x, I have to select the -3. So the line has to cross the -3 on the x-axis. So that means it's going to be a vertical line. It's going to be a solid line. Now I need to decide if I'm going to shade the top or the bottom. And I know some of you guys will say, well, there's no top and bottom, there's only right or left. It says x is greater than -3. So all the numbers that are greater than -3 are to the right. That means we have to shade the right. For the second one, of y is less than 2. So y is going to be a horizontal line. The way I remember to graph it is I'm going to have to go to the y-axis and I'll go to 2. And that'll be a horizontal line. That'll be a dashed line. And then I need to decide if I'm going to shade the top or the bottom. If it's less than, I'm going to have to shade the bottom. You can also test the point. Now if you notice, both of the solutions are on this triangle, on this, in this case it's a square or rectangle. So on this section, which continues all the way to the right, those are the solutions for the inequalities. Now some of you guys might want to shade the right, the bottom, and then just kind of highlight that section to indicate that those are the solutions for both inequalities. Please email me if you have any questions. Have a great day and thank you so much.